Hello and welcome in this new video, and in this video I'm going to teach you how to calculate the equation of the tangent. What I've done is I've picked the question from the ECZ past paper for 27th, which was written on the 27th July 2017, paper 2 mathematics. So this is a GCE paper. So I have a question here which is saying find the equation of the tangent to the curve y is equal to x to the power 2 minus 3x minus 4 at the point where x is 2. Okay, so what do we do when we've been asked to get the equation of the tangent? It's simple. First of all, I'm going to note the curve that I've been given, and the curve is y is equal to x squared minus 3x minus 4. All right, and I know I've been given point x where x is equal to 2. Okay, so every time you've been given one point like x is equal to 2, you have to calculate for y. You need to get the whole coordinate. So we have 2, and that means we only need y. I know that y is equivalent to this. Okay, and I know x is 2, so I can replace where x is in the equation with a 2 to get the value for y. So let's do that. So I'll say y is equal to x is 2 to the power 2 minus 3, x is 2 minus 4. Then I'll say y is equal to 2 to the power 2 is 4 minus 6 minus 4. Okay, so I'll say y is equal to, what is 4 minus 6? That's negative 2. Negative 2 minus 4, that's negative 6. Okay. Okay, now we have y as negative 6. So I'm going to write that in my coordinate. Now I have a full coordinate 2, negative 6. What I can do now is calculate for the tangent, for the gradient of the tangent. So the gradient of the tangent is given by dy dx differentiating the equation given for the curve minus 4. That was a given equation. Okay, so I'll say if I was to differentiate this, the power will multiply with the base and the power will reduce by 1. So 2 multiplied by 1 will give me 2x. The power minus 1 will be 1, so I don't have to write that. Then 3x negative 3. Okay, then this is a constant, which means it's going to give me a 0. So what I have here is the gradient function. Okay, so I can now use the gradient function to get my actual gradient of the tangent by replacing x with a 2. So I'll say 2x is 2 minus 3. Therefore, I'll say 4 minus 3, which is going to give me 1. So the gradient of the tangent is a positive 1. Therefore, I can now get the equation. The equation is y is equal to mx plus c. This is the reason why I was calculating for the gradient, because in the equation, when you have the gradient and the y-intercept, then you have found your equation. So what is y? Y is negative 6. It's equal to, gradient is 1, so I write 1, that is x. X is what? X is 2 plus the y-intercept. So I'll say negative 6 is equal to 2 plus y plus c. Then negative 6 minus 2 is equal to c. So negative 8 is equal to c. Okay, now that I have the y-intercept, I can write my equation. So therefore, the equation of the tangent is y is equal to x plus that's negative 8, just like that. Then I have the equation of the tangent. Let's try the equation of the normal. Hello, now this is 2019, okay? I think it's also GCE paper, and question 6b says find the equation of the normal to the curve y is equal to 5x to the power 3 minus 6x to the power 2 plus 2x plus 5 at the point 1, 2. Okay, so for this one, it's going to be a bit easier than the previous one for the tangent because I have been given a full coordinate 1, 2, so I don't need to calculate for y because x and y have been given. So what I'm going to do is I'm going to write my curve, which is 5x to the power 3 minus 6x to the power 2 plus 2x plus 5. That is my curve, right? Now, the fact that I already have a full coordinate, which is 1, 2, I don't have to calculate for y because y is 2, okay? So what I'm going to do here is that I'm going to go straight by finding the gradient of the tangent. When I find the gradient of the tangent, I'm then going to make the reciprocal of that tangent, then I'll have the gradient of the normal, okay? So the gradient of the tangent is given by the y, the x, by differentiating the curve x to the power 2, x plus 5, okay? So if I differentiate that, I'm going to have 15x, the power multiplied by 15, the power reduces by 1, which is going to give me 2, minus 12x, the power reduces by 1, okay, then I'll have a 1, plus a 2. A 5 is a constant, so it's going to give me a 0, okay? So what I have is the gradient function, okay? The gradient function. Now I can use the gradient function to find the actual gradient by replacing my x with its coefficient value. So I will say 15 and x according to our coordinate is 1. So replace that with 1 to the power 2 minus 12x, which is 1 plus 2, okay? Then I'm going to say 1 to the power 1 is 1 by 15 is 15 minus 12 plus 2, okay? Then that is going to be 15 minus, okay, so that's going to be 10, which is going to give me 5, right? 15 minus 10 is going to be 5. So the gradient of the tangent is 5. Now, the question is asking us to get the equation of the normal. So the equation of the normal, we need to have the gradient of the normal. So the gradient of the normal should be just the reciprocal of the gradient of the tangent. Okay, then you have the gradient of the normal. Therefore, I can say our equation is equal to mx plus c. All I need to find is the c, the y-intercept. Y is what according to our coordinate? Y is a 2. So I'm going to say y is 2 is equal to, my gradient is negative 1 over 5, and x is 1 plus c. Okay, so that is a 2 is equal to negative 1 over 5 plus a c. Then I can make c the subject, so I'm going to have 2 plus 1 over 5 is equal to c, okay? Okay, so 2 plus 1 over 5, it's going to give me 11 over 5 is equal to c, okay? Okay, so you can prove that by saying 2 plus 1 over 5, then you can look for your common denominator is 5. 1 into 5 is 5 multiplied by 2 is 10, plus 5 into 5 is 1 multiplied by that is 1. So it's going to give us 11 over 5. So that's how I got 11 over 5. Okay, now that I have found the y-intercept, I can then say, therefore, the equation of the normal is y is equal to the gradient, which is negative 1 over 5x plus 11 over 5. Then I have the equation of the normal. If you're new to this channel, please subscribe. If you like the video, thumbs up, and let's keep sharing the videos in your groups with friends. And thank you for watching. Stay blessed.